Good morning. So today we will be doing lesson number 22, which is factoring using a method that we call dots. So what I'd like you to do right now for your do now is write down your perfect squares from 1 through 15. Pause this video and come back to check, make sure you have them correct. So here we have our perfect squares. Now remember, there's a trick in the calculator if you want to find your perfect squares. So here I have my calculator. We're going to go to y equals, clear out anything there. Then we're going to click x squared. And how we get the x is the button next to the alpha there. X. And then to square something, we click that button with the squared. Now we're going to hit second. Graph will bring us to a table. And we want to start it at 0. And if we look here, here are all our perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, and 81. And we go so on. And to get out of this, we hit second mode, which quits it. All right, so brainstorm. How do we determine if an exponent is a perfect square? So an exponent is a perfect square if the power is even. So to find the square root of an exponent, what we're going to do is we are going to half it or divide it by 2. So here we want to find the square root of the following. So if I look at question 1, the square root of 36 is 6, because 6 times 6 gives us 36. The square root of x squared is, well, we take the exponent, which is 2, and we divide it by 2, which gives us 1, so it's x to the first, or just x. M to the 6, the square root of that, m to the 6th, we divide it by 2, which gives us m to the third power. So here I have the square root of x squared, y to the 4th. So first I'm going to look at x squared. So the square root of x squared, I divide it by 2, leaves me with just x to the 1st, or x. And then the square root of y to the 4th, I divide it by 2. And that gives me y to the 2nd. So I'd like you to pause this video and try 5 and 6 and come back to check your answers. So let's look at question number 5. The square root of 25 is 5. The square root of x to the 8th is half of that, which is x to the 4th. Square root of y to the 14th is y to the 7th, and the square root of z to the 12th is z to the 6th. So I end up with 5, x to the 4th, y to the 7th, z to the 6th. Number 6, the square root of 121 is 11. The square root of 10 is, a to the 10th is a to the 5th. The square root of b to the 4th is b squared, and the square root of c to the 8th is c to the 4th. So I end up with 11, a to the 5th, b squared, c to the 4th. So now we're going to explore. So I want you to do examples 1 and 2. And expand the following by multiplying and then write it in simplest form. Then I want you to brainstorm and see what do you notice about the binomials that are being multiplied in each problem. We take a look and we double distribute in question number 1. We end up with x squared minus 4x plus 4x minus 16. My positive 4x and my negative 4x will cancel out to 0 and leave me with just x squared minus 16. Then for number 2, I have y squared plus 3y minus 3y minus 9. My positive 3y and my negative 3y will become a 0 when you combine them. And I'm left with y squared minus 9. So what do you notice about the binomials that are being multiplied in each problem? Well, here I have x plus 4 times x minus 4. So it's the same number being multiplied there. Here I have y minus 3 and y plus 3. And do you notice anything about what's in the binomials and then what you get as the result? Well, here I notice that if I have 4 squared, it gives me 16. If I have 3 squared, it gives me 9. So this might help me work backwards to factor, because remember, factoring is undoing that multiplication. And this actually does bring us to what we call our method of dots, which is the difference of 2 squares. So in order to factor using the difference of 2 squares, there's a reason that we call it the difference of 2 squares. So dots actually stands for things. So difference tells us that we need subtraction when we're doing dots. So when we're given a binomial, we need subtraction. 2 means there need to be 2 terms, so we need a binomial in order to do this. And then squares means that both terms needs to be perfect squares. So for example, when we're given dots, we have a binomial, which is 1, 2 terms. We have subtraction, and then they both need to be perfect squares. Now remember, when we're looking at an exponent, if my exponent is even like it is here, it's a perfect square. And then I know 16 is a perfect square, so there are my two squares. Let's look at number 2 here. I have a difference, which is subtraction. Then I have 2, which is a binomial. And then are they perfect squares? My exponent's even, and 9 is a perfect square, so it is. So we would use dots on these. And when we're factoring with our difference of 2 squares or dots method, what we're going to do is we are going to create 2 sets of parentheses. One's always going to be a positive, and one's always going to be a negative. And then we're going to take the perfect square of the first term and put it first in each of the parentheses, and then the perfect square of the second term and put it second. I'm sorry, when I said perfect square, I meant take the square root of that second term and put it in. So in a factored form, the difference of 2 squares can be written as the product of a sum and a difference of the square root of the first term and the second term. So we multiply, we have 2 binomials being multiplied, we have a sum, so we're adding them, and a difference, and then we take the square root of those terms and place them in. So let's do a few examples. So the first thing I want you to do is look and determine if A through G would be a dots problem based on the criteria. So remember, difference means we need subtraction. 2 means it needs to be a binomial. And squares means they need to be perfect squares. So we're going to look here. Look at A. Is this a dots problem or not based on the criteria? So first we look, is there subtraction? And I look here, and no, it would not be a dots problem because there is addition, not subtraction. So let's look at 2x squared minus 16. Is there a difference? Yes, there's a difference. Are there 2 terms? Yes. Are all the terms perfect squares? Is 2 a perfect square? No. So no, this would not be dots because 2 is not a perfect square. Let's look at letter C. I have x to the 4th minus 9. So is there a difference? Yes. Are there 2 terms? Yep. And are both of my terms a perfect square? X to the 4th, that's an even exponent, so that's a perfect square. And 9 is a perfect square. So yes. So it follows all the criteria, so it's dots. So I'd like you to try D, E, F, and G and come back and check your answers. So if I take a look here, letter D would be considered a dots problem because there's a difference, there's subtraction, 2 terms, and y to the 6th is a perfect square, 4x squared is a perfect square. Letter E would not be a dots problem because of this 6 here. 6 is not a perfect square. F would not be a dots problem because there are 1, 2, 3 terms there. And G would not be a dots problem because x cubed 3 is not even, so that means it's not a perfect square. So now I'd like to do some examples where we actually factor. So we're going to look here. First thing we want to look for in question 1, we have x squared minus 36. Does it follow all of the criteria? Is there a difference? So subtraction. There are 2 terms. X squared is a perfect square and 36 is a perfect square. So we have 2 sets of parentheses. In one there's a minus and in one there's a plus. It does not matter if you have the plus first and the minus second. It wouldn't make a difference. So then we want to take the square root of x squared. So we divide that in half, and that leaves me with just x. So since it's first here, it's going to go first in my binomial and then first in the next binomial. Then the square root of 36 is 6, so I put it second here and second here. And then the way that we would check our answers, remember factoring is the reverse of distributing. So I'm going to just multiply these, x minus 6 times x plus 6, and check our work there. So I'm going to do x, double distribute. X times x gives me x squared. X times 6 gives me a positive 6x. Negative 6 times x gives me a negative 6x. And negative 6 times 6 gives me a negative 36. Then I'm going to combine my like terms, 6x and negative 6x, which will become 0. And I'm left with just x squared minus 36. Now if I look here, my original question is the same as what I got in my check. So I know I did it correctly. Let's look at question number 2. So we need to check for dots. Do I have a difference? Yes. Subtraction. 2 terms. Yep. And they are both perfect squares. So I'm going to set up my 2 sets of parentheses. One's a minus and one's a plus, and it doesn't matter which one's which. And I'm going to take my square root of my first term is 144. The square root of that is 12. So I'm going to put that, since that's the first one, it goes first in both of my sets of parentheses. Then the square root of x squared, which is x. So I get my factored answer. So then we're going to check. So I have 12 plus x times 12 minus x. And I need to do my distribution. 12 times 12 gives me 144. And then 12 times x gives me negative 12x. X times 12 gives me a positive 12x. And x times negative x gives me a negative x squared. I combine my like terms. I have negative 12x and a positive 12x, which will become 0. And I'm left with 144 minus x squared. I look and my original question is the same, so I know that I did it correctly. So now let's look at number 3. Is this dots? Do I have a difference? Subtraction. Yep. 2 terms, and are they both perfect squares? 4 is a perfect square. Y squared is a perfect square. 9 is a perfect square. And x to the 4th is a perfect square. So I'm going to set up my 2 sets of parentheses. One's a minus and one's a plus. It does not matter which is which. We're going to take the square root there. So the square root of 4 is 2. And the square root of y squared is y. So 2y goes first. And then I need to take the square root of the second term. The square root of 9 is 3. And the square root of x to the 4th is x to the 2nd. So then if I wanted to check, I have 2y minus 3x squared times 2y plus 3x squared. And I need to double distribute. Or you could use the box method if you prefer. 2y times 2y gives me 4y squared. 2y times 3x squared gives me a plus 6x squared y. Then I have negative 3x squared times 2y, which gives me negative 6x squared y. And negative 3x squared times 3x squared gives me 9x to the 4th. And sorry, I'm running out of space there. Then I'm going to combine my like terms, and they become 0, so I'm left with 4y squared. Sorry, this should be a minus 9x to the 4th. That was a minus there. Then I look here, and they match up, so I know I did it correctly. If you have any questions, please comment them on the video or on the Google Classroom, and please complete practice worksheet number 22.